you notice this kind of question, we will realize that this is the first time in CSIR and UGC-NET that they will provide questions in two variables. Otherwise, they generally asked questions in one variable, either in ZP or ZX or in QX type irreducibility polynomial. So they are asking it for the first time. So let's solve this. We can notice that this second and fourth option is nothing but the same case as we have done in first one variable. They are the cases of one variable. So we can solve them first and then we will see how to solve first and third. So second can easily be seen by using Eisenstein criteria. What does Eisenstein criteria says? That if I have a polynomial of n degree of the form this, say an x ki power n plus a n minus 1, x ki power n minus 1 and so on, a1 x plus a naught, such that there exists and this belongs to zx. This polynomial belongs to zx and there exists a prime p such that P will divide A naught, P will divide A1, P will divide A2 and so on, P will divide An minus 1, but P does not divide An and P square does not divide A naught. P will divide A naught, P will divide A1 and so on, P will divide An minus 1, but P does not divide An and P ki power 2 does not divide A naught. Then in that case, the polynomial is irreducible over Q of X. So if I see this, can I get a prime which divides 10, which divides 25, which divides 100, but does not divide 1, and its square does not divide 10? The answer is yes. P equals to 5 will divide 10, it will divide 25, it will divide 100, it will not divide 1, and P square, which is 25, does not divide 10. So in this case, this polynomial is irreducible over QX. Also, we know that in case of primitive polynomials where the content of the polynomial is 1, that means the GCD of the coefficients is 1, then irreducibility in QX is same as irreducibility in ZX. We have an if and only if result. So we can see that GCD of 1, 100, 25 and 10 is 1. So content is 1. So it is a primitive polynomial. So irreducibility in QX, if and only if irreducibility in ZX. So it implies that yes, it is irreducible over ZX because it is a primitive polynomial. And this is true. Now, if you see the fourth option, this is quite easy to check that we can directly take x square is equals to minus p plus minus b square minus 4ac divided by 2. So this is nothing but minus 4 plus minus 2 by 2, which is equals to minus 3 and minus 2 plus minus 1. So this will be minus 1. So this polynomial can be written as x square plus 1 into x square plus 3. So this is reducible over zx. So this option is false. Now we are left with two options which are in two variables. Now there are multiple ways of solving these kind of two variables irreducible polynomials. But if I have a term like xy, I try to split it into polynomials of the form ax plus by plus c into dx plus ey plus f and try to find a, b, c, d, e, f. And in this case, what I can do is, since it is a polynomial, I can treat it as a polynomial in x and check if the discriminant is a square in q or not. So what I was trying to say is, so for the first option, we can see that we can treat this polynomial as a polynomial of x only. So x square plus we can combine the coefficient of x as y square minus 1 and then the coefficients of x की power 0, which is 1 minus y is equals to 0. Now the discriminant is, if I have to find the value of x in terms of y, then discriminant is nothing but b square minus 4ac. So this will be nothing but y square minus 1, b square minus 4, a is 1 and c is 1 minus 1, 1 minus y. And we can note that this is not a square. This is not a square of any polynomial in Q of y. So this is irreducible in QXY. Since we cannot find the discriminant and I cannot write as x minus some function of y into x minus some another function of y, since discriminant is not a square of any polynomial in Q of y, I can say that yes, this is an irreducible polynomial in QXY. Now, if they asked in ZXY, then the answer is again yes, because it is a primitive polynomial. If I see here as well, the coefficients or the GCD of the coefficients is 1 into 1 comma y square minus 1 comma 1 minus y. Their GCD is 1. So it is again a primitive polynomial. So it is irreducible in ZXY also. Now, for the next, this kind of questions, there are two ways of doing it. The first way is we can directly consider ax plus by plus c into dx plus ey plus f. Or what we can do is we can initially consider this kind of polynomial and we can split this as, if I write this 2x squared plus 3xy plus y squared is equals to ax plus b into by and cx plus dy, then on solving this, we can find the value of a, b, c and d. So can you guess the value of a, b, c and d? So we can see that a into c is 2. So we can take one value as 2 because we want it as an integer. So what we can do is we can take 2x plus y into 2 into x plus y. So we can check 2x square plus 2x plus xy, 3xy and then y square. Yes, this is correct. Now, so this is 2x plus y into x plus y. Now, if I see, this polynomial, then can this polynomial can be written as 2x plus y taken from this plus 1 into x plus y plus 1. So this will be nothing but x plus y plus 1. So this is reducible in QXY. So this option is incorrect. So this option is incorrect. So first and second option are correct. Third and fourth option are